Look at compound inequalities. That means that we are solving two inequalities at the same time. They might be connected by the word and, which means both inequalities must be true. That's called a union of the inequalities. They might be connected by the word or, which means either one of the inequalities could be true, but they don't necessarily both have to be true, and that's called an intersection. Let's take a look at some problems. The first one says y is greater than 5 and y is less than 12. They are already solved, so I'm going to graph them so we can see what they look like. Y is greater than 5 would be a circle on 5 and everything to the right. Y is less than 12. I know 12 would be here, and that means a circle on 12 and everything to the left. But I'm looking for the intersection of those two inequalities, and that means I'm looking for the part of the number line that was shaded in both times. Can you see that it is this section right between the two open circles? Sometimes students might show that by putting their circles above the line and shading in everything that's in between. So that is an intersection. Let's take a look at another intersection. Notice this one's written in what is called interval notation. It is between two numbers, and it's read z plus 2 is greater than 7 and z plus 2 is less than or equal to 11. I can write that as two separate inequalities, and I can put the word and between them. Now I'll solve both of those inequalities. The first one, I will subtract 2 from both sides. Z is greater than 5. And this one, when I subtract 2 from both sides, z is less than or equal to 9. So when I go to graph it, I know that it must be greater than 5, so I'm going to put a circle on the 5 and everything to the right, but it also has to be less than or equal to 9. I'm going to color in 9 and know that everything to the left gets shaded in. So this part is the intersection. If I write that in set notation, I could write it as all z such that, and I could actually write it in interval notation because z is between 5 and 9. I can write it this way, or I can write it down as the two separate inequalities. The last one is an or compound inequality. So I'm going to solve both of them separately. For the first one, I will subtract 11 from both sides, and I get 3 in is less than 2. If I divide both sides by 3, in is less than 2/3. This one, if I divide both sides by 3, I have n is greater than or equal to negative 4. So when I go to graph it, I will put a circle on 2/3. Remember, 2/3 is almost up to 1, so it's going to be about right there. There's a circle there. Everything to the left. And greater than or equal to negative 4, it's a dot on negative 4 and everything to the right. So which part got shaded in? If it's either part that can be true, then the answer to this is the entire line was shaded in, so all real numbers will make this one work.